I'm Steve Wilson.
I'm Deanna Mustafa.
I'm Vincent Piabdat.
Okay, so we had to change our circuit from homework 5 because it was only set to work at one specific temperature. This is how we built the board with 2 batteries in series, giving the op amp an 18-volt power. To reduce voltage for the sensor, we used a non-inverting, which is this side, op amp operation, which reduced the sensor voltage to a positive 4 volts. To do this, we gave it a negative input of -9. And then from the sensor, we used another inverting, on the sensor output, we used another inverting op amp, which converted it to another negative voltage, but we multiplied it by a factor of 27/14. And then once we had that op amp, which would be this first one here, we took that voltage input and we put it in a voltage difference op amp. Using that input as V1, it became a positive voltage. We used a 1-to-1 RF over R ratio, so the voltage didn't change. And then for the other side of the difference op amp, we supplied a -9 volt signal, and we made it equivalent to the -124/175 that we needed to subtract, giving us F over 100 for the final readout. And as you look at the meters, the red meter is the voltage output of the sensor. The black meter is a temperature probe. The temperature probe is more sensitive than that of the sensor, so when we run it, the black meter will climb faster. And now we heat it, and you can see that the black meter went all the way up to like 120 right away. So now as they come back down, the black meter should come down faster, and they should eventually level out. But this is because the temperature sensor is encased in plastic, so for it to actually get to the element that senses temperature, it takes longer for it to get through the plastic, where the temperature probe itself reads it instantly, so that's why it climbs faster.